Chapter 2, Exercise 18. Assume that A and B are subsets of S. List all the different sets that can be made from these three by the use of the binary operations union, intersection, and difference. Right. So if we try to just list out these things without any sort of order, this video would take forever before we manage to get all of them. So what I'm going to do is I'm going to start off with a Venn diagram. Learning from a couple of videos ago, I can just do this. Right? And I'm going to call this big square S. So it's going to be S. Right here. Actually, I am going to color them. So S is going to be this color. This dark blue. Now I'm going to make A green. Make this larger. And I'm going to make B pink. Right, so A and B. Okay, so what I did was consider that here we see that A is a subset of S and B is a subset of S, and we're not assuming anything. We're not assuming that, for instance, B is a subset of S, that they're equal, or that they're disjoint. So let's just leave it like this. This is probably the most general way we can set up this problem, or at least this picture. And what I'm going to do is label each of the regions. So this outside region, I'm going to call 1. This region right here, I'm going to call 2. This one, I'm going to name it 3. And this one will be 4. Okay, cool. So now, all the different sets that we can make are all the possible combinations, all the possible sets using these 4 regions. And this is just a fact from combinatorics. Since there's 4 regions, and we can either include them or not, there's going to be 2 to the 4, which is equal to 16 possible sets. So we went from an unknown number of sets to just 16. So let's make them one by one. So let's do this. So I'm going to label each set by a string containing the numbers of sets included. So to illustrate my point, I'm just going to, give me 1 second. I'm going to add a bunch of pages before I keep going. Because I'm going to keep on duplicating these images. Alright, I hope that's enough. Right, so let's take this image and let's try to construct the set 1. And 1, I'm going to shade it in like this. How do I want to arrange this? I'm going to put it over here. So 1 is going to be everything that is in this outside region. So it's everything that's in S, but it's not in 2, 3, or 4. And that, as you can see, is this region right here. I'm going to color it, I don't know, yellow. This region right here, the yellow region, which is from the picture A union B. Okay, so that's our set 1. Now let's do our set. Sorry, I just keep on moving around, juking all of you. Okay, now let's do the set 2. So the set 2 is going to be, again, this region, and everything outside is not part of our set. It's going to be whatever is in A minus whatever is in B. So it's going to be anything that is in A, so that would correspond to this, but then we're going to take away whatever is in B. So just to do it again, whatever is in A minus whatever is in B, which nets us just this set right here. That's A minus B. Okay, now let's keep on doing this. The set 3 is going to be whatever's in A and B at the same time, so it's going to be A intersect B. And then 4 is going to be B, whatever's in B, but not in A. Oh, sorry, I forgot to label the regions. This. Okay, and now we get into the spicy stuff. So the next set is going to be 1, 2, which is going to be this set right here. Let me make this larger. There we go. Sorry for not filling the whole thing in. This would take forever if I did. Okay, so this is going to be the set S minus B. As you can see, that contains everything that is inside the square but is not in the regions 3 and 4. And now let's do the next set, which I'm going to call 1, 3. So it's going to be this odd thing right here. It's whatever's in region 1 and in region 3. So how do we construct this one? So it's going to be S minus A minus B union S minus B minus A. Yeah. So it's S and we take out A minus B, which is this region, and then we take out B minus A, which is that region. So yeah, there we go. This is our set of 1, 3. Let me center this one. All right. Here we go. Now we're going to do 1, 4. And 1, 4 is this set. Again, apologies for the sloppy coloring. My teachers hated me in kindergarten. Okay, so this is S. Oh, this is S minus A by the same reasoning as 1, 2. So there we go. That's all the ones. Let's start with 1. Now let's do the set 2, 4. And give me 1 second, just for bookkeeping's sake, and so that we don't forget what we're doing, I'm going to do this. Let's put an equal sign here. Move this over there. One day I will plan my videos ahead. Today is not that day. Okay, so let's number them, because this will be nice. So there's 1, there's 2, there's 3, 4, 5, 6, 7, and so this one is 8. I'm gonna put this down here. Oh, why are my 8 so hideous? Okay, 2, 4 is equal to the regions 2 and 4. So this part and this part, and this one is pretty straightforward. It's A minus B union B minus A, which, if you recall, is also known as A plus B. From that one exercise, I think it was 15. Okay, now what's next? Oh, sorry, I did 2, 4. I meant to do 2, 3, just to keep things in order. Let's move U down here and put U up here. Yeah, let's do this. Right, so 2, 3 is going to be this lovely set here, which is just A. Ah, but do we need to use, hmm, do we need to use all the different do we need to use the binary operations necessarily? That's a, that's an interesting question. Well, if you think about it, this is S intersect A, and I'm gonna leave it at that. Okay, 9. This set that we'd already established. 10 is gonna be 2, 4, so the next one should be 3, 4, which is equal to this errore, which is S intersect B. Now, what next? 11. Now we're starting to get into the ones that need 3 numbers. It's going to be 1, 2, 3, which is this stuff. So I'm going to call it, I'm going to call this set S minus B minus A. So everything except for region 4. Now, what is it, 12? 12. 12 is going to be, if we did 1, 2, 3, let's do 1, 2, 4. And that is, mm, Yeah, 1, 2, and 4. So it's just S minus A and B combined, or the intersection of A and B. Next up, we're going to have the set number 13. Whoops, almost dropped my tablet. 13, which is 1, 3, 4. So this is the analog to the earlier set. On the other side. And this is going to be uh, equal to, sorry, I put colons here. All right, just for consistency. Okay, so 1, 3, 4 is S minus A minus B, and I'm going to call it a day. Now we have the set number 14, which is going to be 2, 3, 4, which thankfully is not too complicated. It's just these two. And this, you may recall, is also called A and B. Next up, set number 15, which is our set with all of them. That's going to be what regions 1, 2, 3, and 4. And this, you might just see it as S, but I'm going to get fancy and call it S intersect, I don't know, B minus A union S. Because why not? But this is also just equal to S intersect S, which is just equal to S. Okay. And finally, we have set number 16, and you may be wondering what that is. And the last set we can construct with these operations is the set that contains none of the regions. That's going to be S minus S, or rather, I'm going to call it 0, which is equal to S minus S, which is the empty set. And that's all. That is all the sets. At least this is my interpretation of what Enderton was asking, because I have to say this is kind of an ambiguous prompt in my opinion. Like, list all the different sets that can be made. I mean, if you just keep going, well, I guess they are equal. Up to equality, I think we've listed all the sets that we can make by using these binary operations. Now, I don't know if he meant when you use all three of them. So you use A, B, and S in one set, and then change the union, intersection, and difference operators around. I don't know, but this is the best I can come up with, and I think it's a good enough answer. With that said, I hope this was helpful, and I will see you in the next video. Bye bye.